Now we get to the exciting stuff. So as you've already seen from the last two presentations, we did a lot of work to make Windows able to use what we like to call dynamic access control. And there are many different types of dynamic access control. Rich expressions is one thing, which doesn't require any protocol enhancements. But the other two, like claim support and compounding, require the fact that CURB, as an authentication protocol, can transport that data to the target server. We also added the armoring support from FAST. So if you look at FAST, it is really a framework. The piece of the framework that you're really going to see when we talk about details is leveraging the armoring. I'm not going to go into FAST since this is an RFC, and we're just covering a lot of things. I'd like to talk about the extensions to make sure that that is something that you go away with. The last thing is packed resource SID compression. So if we're going to look at how you extended Kerberos, it's always good to make sure everybody's on the same page on what does Kerberos do, right? What does it look like before it was extended? So for regular Kerb, you have this AS-ping, right? We've had this since Vista. This is a way for Kerberos to figure out what kind of encryption types you support. Then you get a Kerberos error back from the KDC that gives you a whole bunch of information, one of which is the error type, or sorry, the E-type. Then we do what we call an authentication service request, or I sometimes also refer to this as initial authentication. So something's authenticated, they provided some kind of credentials, you need to provide that, create an authenticator from that, provide that to KDC. The KDC then validates that, hey, you must have had the secret you're supposed to have, and we'll send back an AS reply containing what we call the privileged attribute certificate, which contains authorization data and some things that WinLogon needs when it starts up and creates a desktop for a user. So after you've done that, you need to get a service ticket, right? So you have this data structure containing a bunch of information that other services may need. You're going to provide that, which we call, it's wrapped in something we call a ticket granting ticket, and you're going to ask for a service ticket, right? So if we're looking at interactive logon, we need a service ticket to this box, right? User needs a ticket to this box. If we're looking at what most of these discussions today are, which is going to an application server, you're going to need a service ticket to the application server. So I want to go over here to this application server. I ask for a ticket, get my service ticket back, and a reply. Right? So the KDC just copies the pack information out of the ticket, gives it to the Kerb client. The one piece that a lot of people forget because they see the traditional diagram is that then the application protocol shows up, right? So these are all going to be TCP or UDP messages, right? This here, the application protocol gets what is often referred to as a token and passes that. So inside of whatever application that may be, you're going to see this Kerb AP request going through. This has the service ticket and a validator that proves that the client has the shared secret, and then the application server will open up that message in order to build the token. And hopefully, that application server is also going to respond back with its response, so we have mutual auth availability. So when we look at claims, so claims requires quite a bit of change to the infrastructure because we have a lot of players that have to be claims aware in order to support claims. If we have two forests, then you need to have the roots of both forests need to be able to understand claims. Obviously, when the client does its initial authentication, you need to talk to a KDC that understands claims. And then, in order to use claims for access control, you need a server that supports claims in order to use it. So the only player is possibly referral KDCs and the resource domain KDCs. The only one that really doesn't have to know any of the new stuff. So what you're going to see is first, the client is going to send a Kerberos AS request with claims, right? I want to authenticate with claims. Then the domain controller is going to go and collect the claims through that great 80 voodoo magic that we learned about earlier today, right? It gives back that information to Kerberos along with groups that it always has, and then that comes back in the AS reply, right? So now I have a service, I basically have a TGT. Inside the TGT, I have a pack that has claims in it. Now I need to connect to this file server here, so I'm going to send my Kerberos ticket request saying that I have claims. And this domain, since file server belongs in domain D, domain A is going to say, now you need to go talk to the next KDC in the referral path. So again, I'm like, hey, domain B, I would like to get a service ticket with my claims, service ticket for this file server, and domain B is now the root of that user's domain. If you've configured what we call egress claims, in other words, or egress transformations, if what you want to do is say, you know what, I don't really want other people to see what all my claims are, so I'm going to either change them or get rid of them, right? Because, hey, you don't need to know that about my users, or that's what we call them here at Microsoft, but at your company, I want to call them something different. So they're going to transform those claims in whatever way they've been configured to, and then repackage them into a referral ticket saying, go talk to domain C, right? That's kind of an optional step. You don't have to transform claims on the way out. If you'd like to, that's great. But it's more of a privacy thing. Coming into your domain, at this point, you want every in that root domain to be Windows A, right? Because they are that first line of defense. As these claims are coming in, they're going to look at them. And if any of those claims are claims, because claims are just a string, what are the odds that you and I, when we think of an attribute, name it the same thing, right? Quite possibly, right? So it'll translate those through transformation into the claims that we understand, right? So it may drop some things because it's like, we don't care about that, about this user. Or it may say, okay, you say that you're a program manager at Microsoft, you are an external partner to me, that's what we call you guys, right? So that you can do access control based on that. And what we get back is referral TGT, because we still are not at the right domain controller. So at this point, the client gets a referral TGT to domain D. Once again, as it's said now 3 times, I would like a service ticket to the file server with my cool claim service ticket, or TGT. The domain D now is actually the right guy. So at this point, he does what he normally does. He just copies things from the pack into a ticket and send, oops, sorry, that's a mistake on my part. That should be a curved TGS reply at that point. Cut and paste error. Now that we have the ticket, we can do the AP request. Again, this is wrapped up in some application protocol, which is not shown on the slide. And then we send the reply back for mutual auth, right? So when you look at claims and you're looking at MS Kyle and you're trying to figure out what's going on, you're going to find that this information is interlaced through everything in the domain controller. Client thing is really clear, right? Because you saw the client is pretty simplistic. Hey, I want claims. Hey, I got claims. Hey, I got claims, right? They just be very consistent. The domain controller is the one that has to go, okay, I understand claims. Now I need to do this, now I need to do that. Any questions about claims? I'm not going super deep in any pieces, but I'm more than willing to pull up a technical document and talk deep if that's what you want to hear.
In number 14,
Yep.
the ticket would have the claims in there.
Yes, it'll have the claims in there. Yeah. And keep in mind, the way that, actually, how many of you guys implement Kerberos? I'm maybe the only one in the room. All right, so there's 3 or 4 of us. So for the rest of you that don't implement Kerberos, the KDC just copies all of this stuff over and over again. And that's why this domain controller here doesn't even have to be claims aware, because it's saying, okay, you got this authorization data, okay, I'm just going to copy it for the next guy, right? And so throughout here, only the guys that know stuff actually go into authorization data and tweak it. And so that's why I called out those 2 guys, because they will actually tweak the claims. But if you didn't have anybody other than domain A that understood claims, you would see that the claims blob would be the same claims blob that you got originally. Okay, so the next thing that's really interesting is compound authentication message flow. And as Ganga pointed out, this is just an extension of the armoring that is in FAST. So this one's a little simpler. We don't need as many hops. But what I wanted to do is make clear that it's during the TGS that you need up level, and if I just had one domain controller, it wouldn't be so clear for you. So we've got domain A here, which knows nothing about compounding, maybe not even nothing, doesn't know anything about claims either, right? So the client is going to ask for a service ticket to its domain controller. That domain controller says, oh, you know, that server doesn't belong to me. Here is a referral TGT to the file server, right? Then that client is going to go ahead and it's going to send an armored Kerberos request, right? So it knows that domain B, right? It's going to go ahead and since that supports FAST, it's going to send it armored. And this is just straight out of the RC, plain vanilla, FAST. It gets back an armored response. And the client is going to look at the E-types. And actually, I probably should have called this out. This isn't technically the MSDS supported E-types, but in our implementation, what would happen is on domain B, the contents of this is put in the E-type support bit that the client gets, right? So when a client gets a ticket and it gets a session key, right? So there's an encrypted piece of data that's for the client, right? That's protected. In there is the ticket, which it can't use, doesn't have the key for. It has a session key it's supposed to use whenever it uses the ticket, and it has like a series of fields that it can read, right? Of that information this is the encryption that the other server supports. Okay? In there we use high order bits, and one of them is for compound identity supported, and so when this is set, it's true. Might be a little bit clearer if we look at the document, since we've got a lot of people that to figure out which document it is. So, not that one. Not sure what that one is. Okay, so if we look at Sorry, it's in messages. So if we look at the message types, there's a field called the PA pack options, right, which is not PA options, sorry, PA supported ink types, right? That's what we're actually reading in the message. There is also this bit flag in it. So, right? So, low order bits, E types, been there for quite a while. Since Vista, high order bits are these new features, right? So it's going to look in that E-type, PA data type, right, inside the message. And it's going to look for this bit, G, and if it's a 1, right, it says, hey, you support compound authentication. If it's a 0, it says, okay, I'm done. There's nothing else I can do here. So back to the presentation. Okay, so that bit was set. And I, as the client, say, okay, you support compounding. Great. I'm going to go ahead. I'm going to send an ASREC now with explicit armoring. So previously, if you look at FAST, armoring is normally based on the identity of whatever that caller is. So this would have been armored with the user's TGT. Here, we're now going to armor with the device's TGT, right? Because we have two identities, right? We've got the identity of the machine I'm setting on, my identity, and now I can bind those two identities together using explicit armoring. When I use the explicit armoring, the KDC says, okay, great. That means now you want a compounded authentication. It will armor it back because that's how armoring works. And now the service ticket I have has that device's information in it. And then inside of my application protocol, I give my normal AP request. It responds back with the AP reply. Okay. Any questions? Now, we only opt in for compounding, mainly because why send more data when you don't have to, right? Why do this extra leg? Why create a data structure that isn't used? But because of the way that Curb works, right, it's not gonna, if it gets data that it can't use, it would just throw it away anyways, right, and you just wouldn't get an access token with it. So that's what you're gonna see probably some people do is, if you do a misconfiguration, like let's say, since I can put this setting on a Windows 7 box, that's an easy thing for me to do. I can just go into PowerShell, type this, and turn it on. Does anything exciting happen? Not really. I get a bigger service ticket passed to me, and then when I build the access token, all the device stuff isn't used. So, or claims for that matter either. Any questions? Okay, pack compression. So we already do pack research. We do pack account SID compression already. And if you looked at the documentation, you saw that Kerberos application servers already supported the ability to receive compressed resources. So what this means is when you look inside of the pack, actually let's do that. When you look inside the pack data structure, what you will see is a whole bunch of goo. But what you'll see is we call out, here's the user, here's his primary group. Notice we talk about the logon domain, right? And then when you look at the groups for this, it's a group count with these different IDs, right? So we have already compressed here. We can see, and this hasn't changed since, probably late Windows 2000. You see that we still have the same ability here for resources, right? So resource group domain, group count, list of IDs, right? And then we have another setting, which is extra, where is it? I know it's in here because I know the description is lower down, so I can't imagine that the actual thing. Is it down at the bottom?
Extra sits.
Fourth from the bottom. Oh, here it is. That's why, because I keep missing it. So you can see that this is a P group membership type, this is a P group membership type, this is a P curb SID and attributes. So this extra SIDs is a list of SIDs. So back to the slide. That gives you a little bit more context now when we look at the slide. So, there we go. All right? So, today, again, count, and by today I mean Windows 7. So in Windows 7, Windows 2000 through Windows 7, what you see is in the account, right, we break it out all nice and neat, and then all the resources, universal groups, well-known SIDs are like this in that extra SIDs thing, right? They're just a list of SIDs, which isn't terribly efficient because we already had the ability to do resource. So when you hear compression or SID compression in the curb context, what that means is we have a field where we put the domain SID information, and then we have a list where we just put the rows, right? So instead of taking this much space, we take up this much space. Does that make sense? And Windows 8 does this automatically, so once you start deploying Windows 8 DCs, what you're going to see is this compression is just going to automatically happen, right? And the reason for that is because all versions of Windows are good with that, right? Fully patched Windows 2000 up to today can all consume this information in the compressed format. Yes?
Then there's really no negotiation for that from the server application side, right? It just has to accept the new format.
Well, we did take into account that the world is not all about us. And when the world is not all about you, you need to prepare for the fact that, maybe not everybody can do what you do. So what you can do is on the domain controller, right, as we said, every E-type, we have this field for the MSDS support encryption type attribute for every object. So what you can do is opt out. So if this bit is set on the account object in AD, when AD is giving you a ticket to that one, it's not going to do compression. So if any of you have an implementation that isn't, the same as the Windows implementation or based on how we described it in MS Kyle, and MSPAC where you can do resource compression, then all we need to do is just, there's a PowerShell commandlet for whatever the object is, computer, user, service account. You just set, oh wait, no, sorry, I'm correct. That's incorrect. You'd have to literally use LDAP or PowerShell with explicit in order to set that. We don't actually have a field. If you think that's going to be a big deal, now would be the time to make sure we understand that. I can see, about extending PowerShell for that. But we didn't think it's really going to be that much of a problem. Okay. Any other questions? Awesome. You guys are so quiet. All right, so MSPAC. Obviously, if we're going to transport new authorization data, the data structure we use to transport that data structure has to be extended. This stands to reason. So, as normal for a protocol, it's hard for you to change an existing thing, but you can add new things to it. So in MSPAC, we've added 3 new data structure types. One has the client's claims info. One has, darn it, I did it again. One has the device info, and one has the device claims infrastructure. And then in the security considerations section, we mention the need for transforming. And transforming itself, as far as how claims transformation works, is in ADTS 311.10.2.10, right? Basically, just you can go into PAC, go to security considerations, and I put the exact same information, and thanks to our great writers, there's like a link you click and it goes places. So that's probably the best way to get there. Right. Any questions or curiosity about those structures, or? Okay, all right. It's all defined in the document, okay, so MSPKCA, KA, PKI init. So these are the extensions that Microsoft has to our PKI-based initial authentication, right? The big thing that we did is we added support for computer accounts. So I'm not sure how many people have noticed this, because in Windows we only supported smart card logon, but basically KDCs can log you on if you weren't a user with PKI init. So we've made an extension here. It's described in the document. Is anybody curious about it? Because like I said, we can pull up PKI init. There are some new criteria for computer account certificates. Obviously, if we're going to add support for something now, it's going to be based on the current standards. So you can't do, for example, computer PKI init without the strict, what we call strict KDC validation type KDC certificates. In other words, you have to have the RFC type KDC certificates with the OID, or sorry, the EKU for KDC. And there are some naming restrictions as well. Constrained delegation. So we have a document called MSSFU, which documents 2 different protocols. One is the, we've named cryptically the SFU to self protocol, right? Services for user to self, and the SFU to proxy, services to user for proxy. Also known as in IT pro documentation, protocol transition, and constrained delegation. The protocol transition is really self plus proxy. So we've added cross-domain support. One of the most popular things that's been requested for me is I want to be able to do constrained delegation and have my middle tier and my back end in 2 different domains. Why doesn't that work? And the reason that it didn't work is because we chose to enforce it on the wrong thing. So since it was enforced on the middle tier, you couldn't hop. What we've done is we've created resource-based provisioning in Win8, and now we can cross domains. So when you're doing resource-based access, you're going to need a middle tier that knows the new stuff, and then the back end and the front end need to know the new protocol. Referrals don't have to be up-level or extended. So when you have a client, and the client doesn't have to be Windows 8, it could be Windows 7, it could be XP, whatever. As long as it's doing RC, that's fine. It's now asking for a service ticket. It says, hey, I need a service ticket to the web server. This is how all constrained delegation that isn't, by self, right, that isn't a protocol transition works. I get a service ticket to the web server, and then of course, through my application protocol, I connect to the web server. Now the web server says, okay, you've decided, the application's like, okay, you need to do something. In order to finish that task, I need to talk to this, say, SQL server in order to get that information back to you. So I'm going to need a service ticket for the SQL server that I can use on your behalf. So it's going to basically start doing the proxy piece, right? So at this point it says, hey, I need an S for you to self-proxy, right, using that protocol for the SQL server. Since Domain doesn't own that account, and it supports resource-based constrained delegation, it's going to send a referral TGT. This now says, okay, great, I need a referral TGT, so that means I'm going to go to Domain B. So I basically have an S for you to proxy request for this guy with this. Since Domain B understands the new thing, it's going to check the new attribute. If the account for that web server is in the attribute for this account, it's going to go ahead and issue a service ticket. Since that's true, I get my reply via proxy, and now I can do a normal request. Oop, I didn't put mutual auth there. Okay, so any questions about constraining? Okay, so the last thing I'm going to talk about is the only new protocol document and the only new protocol that we have, and that is our KDC proxy. So KDC proxy has two roles, the actual KDC proxy, which is the server role, and the Kerberos proxy client. Why we have this is to provide Kerberos authentication for our direct access and remote desktop scenarios. Basically, they have Kerberos clients that are out on the internet or basically not on the network with the domain controllers, and they need to have Kerberos service tickets to those edge servers. The nice thing about the Kerberos proxy solution is it ensures that Kerberos messages are always protected by TLS SSL. This was important to us. I mean, one of the alternatives we looked at was something called IAKerb, which is an RFC, but you are dependent on the fact that the application is protecting that data. So if the application is not protecting that data, you're sending curb messages in the clear. Not really desirable for us because since one of those is probably a password-based ASRAC, those are susceptible to offline dictionary attacks. We don't really want those in the clear. Also a requirement that was very clear to us from direct access and remote desktop is that nobody's updating domain controllers for this. Right? You need to make this work so that any domain controller will work, right? Any KDC will work. Another solution as far as our IAKerb is that we could armor, but as we saw, right, armoring requires up-level DCs. Also, we need to support both domain join and workgroup devices, which means sometimes there's no device identity. And the other requirement that was needed for remote desktop is it needs to support change password, right? So now we're outside of the GSS API handshake. The KDC proxy is actually a pretty simple concept. What happens is that the client establishes an HTTPS, it's a web server, so there's a secure channel to the web server. Then your AS ping, it forwards, right? It says, oh, here's the AS ping. It gets the response back. It gives it back to the client. Client sends the AS rec. AS rec goes through. Then we come back. Same thing. Now I need a ticket. So it goes and asks for a ticket. And then that response comes back. Now we can connect to that edge server using whatever application protocol that direct access or remote desktop uses and do our normal request and reply. Any questions about that? Wow, you guys are really quiet. Okay, great.
Is it really that simple?
Yes, it's really that simple. There's a little bit of header stuff.
Repeat the question.
No, sorry, the question is it really that simple? And the answer is yes, it's really that simple. There's a little stuff in the header. I mean, if you're going to implement your own KDC proxy, there would be things that are not protocol-based that you'd have to probably do. Like, for example, nobody wants me passing other random non-Kerberos message packets onto CorpNet, right? So yes, our proxy's smart enough that if you're not a Curb message, we're a web service, so you can do mutual auth if you want. That's really more of a property of being a web service, not necessarily a proxy. So there is some smarts in our proxy because we have this Windows 8 features that require Windows 8 DCs. So if the client's consuming one of those, that's something we need to know for DC location. Right? But aside from that, yeah, it's very, very simple. It is also very, very performant, which isn't actually a good thing on the edge. But luckily, we're co-located with these edge servers that have lots of things to do.
How are the edge server trusted by the domain controller? How are the edge server trusted by the domain controllers?
So there's no trust in, okay, there is obviously trust in Curb, but you can't, authentication protocols don't have many safeguards, right? Because they have to accept anonymous connections. I mean, when you look at a protocol and you think about how do I harden a protocol and how do I harden my service, the first thing people throw there as a speed bump is, okay, you have to authenticate to me. No auth server can do that, right? Authentication servers by design have to accept things that have no identity so that it can authenticate them.
I'm more referring to the edge server and the domain controller. So do you need a certificate for edge server?
No, because like I said, it's in Curb, there's nothing here, right? This is just the edge server is a Kerberos client. It opens a TCP connection, It sends the message, the domain controller does its response, right? I could take the edge server out and it's the exact same thing you'd see client to it. I mean, it is literally a proxy.
It's part of domain. Edge server is part of the controller.
Yeah, I mean, most of the things on the edge, but I mean, it's not authenticating. So it's actually kind of irrelevant what its identity is because it's not providing it. Right? TCP, again, right, it's just a connection to a port, right? And then you're going to look and you're going to see these messages, right? These messages are designed to be anonymous, right, up to this point. From here on out, well, actually, that's not true. So from here, it's anonymous, obviously, because it's ASP. But here, I mean, you're going to provide your validator. Validator happens, but, I mean, there's no authentication between these two guys. It's standard Curb.
How is this different from like using MIT Kerberos library to do this today? I mean, I'm a little bit confused. This is a new protocol, right? So today you can use MIT.
This is a new protocol, right? This is how it looks, right? Only this piece is new. And like I said, all it is a wrapper. I mean, this is the easiest doc ever for writing. Granted, I've owned some complex things, but I mean, if we look at the document, this total document is 18 pages, right, up to security considerations. The client section is 2 pages long, and the server section is 3 pages long. I mean, if that doesn't tell you something. And if you look into it, that's even me creating an abstraction, right, that the proxy message, because obviously if we're going to plug this into the document base, somehow the Curb client has to call into the proxy client in order to get this started. So you'll notice that Kyle also has an extension where it says, I can't find a domain controller, so I'm going to try proxy, right? So that's just the API that says, hey, I can't find a domain controller, try and see if a proxy can do that, right? So you've got the URL specified, all of that kind of thing, right? So, I mean, this is, I think we got some formatting things. This is the message definition, these 3 things. Oh, sorry, go ahead.
You're matching.
Right, so when you look at it, it's HTTP message with this field, and this field, right? This field is that Curb message, the normal one. This one tells you what the target domain is, and this is some domain hint piece. Yes, sir.
You just say, if I can't connect to the domain controllers, when you say I can't connect to the domain controllers, you mean domain controllers or KDC?
Oh, my apologies. Yes, it would be KDC because it's Curb.
So it's basically it means that
in Windows it's the same beast, because in Windows what the client does is it asks DC Locator. DC Locator only knows how to find domain controllers, right? And so yes.
I mean, basically it means that this protocol could be used by non-Windows client
Oh sure, yeah.
without, I mean, needing to have the full-blown RPC stack to do AD.
That's why this is 2 to 3 pages long per role, right? All you need to do is the client needs to know the message, right? And here it is. So you need to know what the URL is that you're going to. You create just a normal, secure HTTP connection to the URL. You pass this message, right? And that's pretty much it. Mm-hmm. Oh.
And then in this scenario, the application server, I see the use case where it's sitting internal to the network and it's behind the firewall. But I guess this also allows you to basically do a domain join with an application server and then move it anywhere you want outside the firewall, and the client can now talk to it through the proxy.
Yeah, I mean this solves the problems in which you could use NTLM but you couldn't use curve. Right, so that was a common complaint I heard is, we know that there are some issues with NTLM, we don't really want to support it, why can't negotiate work with curve server? So that's pretty much what the role that it filled, if that makes any sense. So if you look at the two features, direct access, right? Direct access actually had their own mechanism using certificates that they used. You've ever seen, it's based on IPsec, it did some bootstrapping based on certificates. Remote desktop gateway actually used TLS. So what happened is you made a TLS, a mutual auth connection to the gateway, and then it did protocol transition, right? And what it would rather do is get out of this business, right? So we can do this for them, and then they get a ticket. And that way they work exactly the same inside the network as they do on the edge. And then, like I said, the KDC proxy message is, again, pretty straightforward, right? So it finds the right DC and it sends the message. So and then it creates the exact same message back, right? You don't need to give it a hint back because the client's not going to use it. But basically, I'm not going to tell you a target because there is no target, but we use the same message basically, and it's just going to send the message back. And then the client has the current message. So, like I said, I've never had an easier document to write. Though it is still 18 pages. Any other questions or comments? All right. So
if you're interested in other auth protocols used in the Windows system, Ganga last year in 2011 at the Plugfest presented the AuthSoD overview document, which includes a number of the protocol specifications required for authentication, and that is a very useful reference. And Michiko actually answered some of the questions during that session. So that's recorded and available on Channel 9 as well as this presentation, which will be posted. Tomorrow we'll be providing, with the test team, Dexter and Min and some of the others who are here, Randy, you will be able to go through those scenarios on the wire and run some test tools and also run it against, some of you are already doing that, running it against your systems.
Well, we'll give you a heads up that when you look at like Windows 8 clients with Windows 8 domain controllers with the new features on, I had the nice presentation showing you all, actually 2 of the 3, there's also fast there as well, right, separated. Windows doesn't do that, right? You're either a Windows 8 DC, which means I know all the features, which means the clients go, I know all the features, and basically you're going to take, if you had a slide for claims and fast and compound ID and stuck them all together, that's what your wires traffic's going to look like. So this one, when you look at it, the purpose of this was so that you can understand each of these, because I am not at all suggesting that everybody in the world must do like we do and support all 3 things. You may choose to just do claims. You may choose just to do compound, that's fine. You may just do resource compression. So the point is that it's not as clean because in a normal environment, like if you light up your entire infrastructure with Win8 domains, right? These, claims, compound, and Kerberos Armor supported domains. Then, the clients that also support all three things are going to do armoring for the claims requests. They're going to do armoring for referrals, and then, the compound piece is pretty much very solid.
And just a reminder that Ganga's AZOD overview presentation is the first overview document which includes the Windows 8 protocol specifications. So AuthSOD at this time does not yet include the Windows 8 protocols.
Oh, we did some of them. Didn't we put some updates? Yeah, I think we did.
Did you get some of them in there?
Yeah, we did update.
Okay.
I have to redo the map. That was one thing I noticed when looking, but other than that, I think if anything is missing, we need to know, because we thought we finished that one.
Great. So on the March, because we have the March release, which was when we updated the protocol specifications to include the Windows 8 beta, which the specifications are relatively inclusive of those Windows 8 protocols at this point. So apparently AuthSOD
Yep.
does include the Windows 8 behaviors. Okay, great. So that'll complement, as Ganga said, that covers the other piece. He covered authorization in AZOD, and that covers authentication. So thank you for that clarification.
Yep. And those docs will be updated for any of the RC changes that impact protocols. Obviously, we do the RC.
Right.
You know when that is, or we don't know yet?
We don't, well, we just published, it actually hit in April. There will be another 3 months. There's expected cycle would be 3 months.
Okay.
But there will be, regardless of what happens with Windows, we will be updating the specifications in another 3 months on that cycle. And that will be on the Windows 8 life cycle. So whatever happens with the releases in those coming months, you'll see those changes reflected as they roll out. Yes.
So I've got one more question.
He's patiently waiting for the microphone, and you're just gonna stand around.
So one more question is, how do clients locate the proxy? Or is it supposed that the proxy is going to be the web server?
So, okay, so the way that works is that the remote desktop, and this is our implementation, you can do whatever you want. The remote desktop client and the direct access client provide that when they do their calls. So it's part of the whole GSS API. They'll set the credentials saying, hey, there's a proxy available, and the Kerberos client will then use that because it now has a URL. Something has to provision that URL on the client. How you want to do that, of course, is up to you. So in Windows, we have a group policy option, and then, like I said, normally, because those are only 2 scenarios currently, the client sets that. Because you can see that there could be a future where one client wants to use one proxy and another client wants to use another proxy, so setting it globally on a Kerberos client doesn't make sense because you'll go to the wrong guy. So this way you can go to the DA's proxy for DA calls, and you can go to the remote desktop proxy for remote desktop calls.
Is there any plan to use DNS record for proxy location?
I mean, we can always do anything. In the future, at this point, it is a solution for 2 solutions, and those 2 solutions have to provision the client side. So we, haven't gone anywhere else. I mean, there's many ways you can go. I mean, if the idea is that the world needs a standalone KDC proxy, then everything will change a little bit, right? So. No other questions? Wow, you're like the nicest group. This is what, my 6th year or something at this? This group is the quietest.
They are very relaxed. I mean, and focused. I mean, you see these guys from here till 9 o'clock at night, some of them, debugging, and I mean, this is a really diligent group.
Well, it is a lot of information. I expect that once you start digging in the documents, the we'll start getting questions. And we'll-
Thank you, Michiko, very much. If you have any auth questions, there will be another chance to circle back to auth again tomorrow with, we're going to revisit the overview document, auth.so.d, that we just mentioned, with some of the focusing on Win 7's test scenarios tomorrow. From, like I said, Dexter and Min and Gucheng and Randy are here. So Yuching is off in the lab, I know that. So these guys will be here demonstrating some of the test scenarios that they've done with Windows and non-Windows. For today, just wrapping up, we've got we're going to take a 15-minute break, let you go. Please do fill out the surveys we've given you. Hopefully these sessions are helpful to you, as Michael and I have been saying all week. We look for your feedback on all of these sessions, the information that we've presented to you. We continue to try to come up with ideas for improvement. One idea we've got, we're going to try tomorrow with Matt has volunteered to do our first implementers presentation tomorrow afternoon. So that'll be interesting. In June, we're going to actually do a pilot with that and invite you as the partners. So some of you file implementers out there, I'm looking at some of you. I know that some of you will be here for SMB. We want you to come and tell us about your implementation. So we haven't really done that here at the Plugfest before on campus. Anyway, do provide your feedback. At 3 o'clock, we'll come back and cover the ADOD scenarios from the test team and look for your feedback on that. And that will be the end of the day. Beyond that, we'll continue to remain. The offices will be available. You can come to us one-on-one to talk, and if you want to go through a demo of the test suite actually in your lab. Some of you have non-Windows implementations that we've already tested against, either man in the middle or some other implementation. So we're certain the file server implementations. You're certainly welcome to test those scenarios with us.
Okay,
Thank
so earlier somebody asked about what the claim structure was, and if you remember, I was like, I'm Curb, it's okay. Not everybody is as blessed as I am to have an AD team that can handle all these technical details. So I know some of you guys are going to have to pack your claims. Inside of MS ADTS, we do document what the wire structure is for claims, so that is all out there and published, so you can see what that is. Like I said, from a Curb perspective, we just said, hey, you get this blog, thank you. But if you actually have to touch the blog, which a lot of people do, then you need to know the contents. Right? So, like I said, everything is documented. So, you know, and we did put breadcrumbs. So, like if you're in the Curb document, it talks about claims. It'll have this. You know,
I think this